Good evening and welcome, listeners, to Cafe de Flore. Cafe de Flore is a server dedicated to education and debate where we discuss issues in philosophy, politics, the sciences, and the arts. My name is Stephen, and I'm joined tonight by Dr. Luke Barnes, who has generously agreed to take time out of his day to answer questions from our community. A recording of tonight's event will eventually be hosted on the Cafe de Flore YouTube channel, a link to which can be found at twitter.com/shinybaboon, and also down in the AMA discussion channel, where I'll also post announcements about upcoming events. The Twitter, that is. With that being said, I'll now briefly introduce our guest. Luke Barnes is a theoretical astrophysicist and cosmologist who lectures at Western Sydney University. With a PhD from the University of Cambridge, he has published papers in the fields of galaxy formation and the fine-tuning of the universe for life. He co-authored the book A Fortunate Universe, Life in a Finely Tuned Cosmos with Geraint Lewis, and he has published papers on the philosophy of science as well. Luke regularly engages in public outreach through public speaking, articles in the popular press, and social media, appearing on YouTube shows such as Capturing Christianity and Digital Gnosis, and we're very honored to have him here with us today. Luke, thanks so much for being here.
Thanks for having me.
So what we're going to do now is we're going to move on to about 90 minutes of audience questions, where I'll be reading out the questions from the AMA questions channel and unmuting anyone who wants to ask Luke a question directly. If you submit a question and want to ask in voice chat, be sure to indicate that somewhere in your question, preferably by including the letters VC in an obvious location. So with all that out of the way, are you ready to begin, Luke?
Yeah, hit it.
All right, excellent. So to start off here, we have a question from SP, which I think is a good question to start off with. So how did you come to the conclusion that if the parameters of the universe were different, no life would exist? What are these conditions that are needed for life to form?
Well, what happened sort of historically, and this was, we're talking here in the 70s and the 80s, is what theoretical physicists would do with any theory, what you do with any model, which is if there are free parameters in the model, you see what happens when you change those free parameters. That's just an absolutely standard thing you do with a model. Now, if your model is worth anything, as a physical model, you should be able to, ask that model questions about what the universe would be like, right? So you can ask Newton's theory of gravity. If the sun weighs this much and the earth weighs that much and it's this far away and it goes around in a circular orbit, how long until it gets all the way around? So you can just ask. That's the whole point of having a theoretical model. You should be able to ask it questions, which you could also ask the universe via actual experiments. What they noticed was that when they changed some of the numbers in the sort of deepest laws of nature that we know about, that what are now known as the standard models, that you didn't just get a sort of slightly different universe with, slightly heavier this or slightly lighter that, or this connects in a slightly different way. Quite often, some really drastic changes turned up. Some rather remarkably drastic changes, and in particular changes in the direction of simplicity. The reason why our universe is hard to work out is because it's complex. I'm currently looking out my window at a small bird that's outside, right? That is an incredibly complicated physical thing. But if you make a universe where the universe remains homogeneous, completely smooth matter distribution, so the same amount of stuff in every little bit of the universe, that's a really easy universe to describe. We can write down the equations for that and solve them, and hey presto, we know everything that's going on in that universe. And in particular, we know that there's nothing as complicated as a bird because we know everything that's going on in that universe, because it's an easy universe to solve. It's not like our universe, which is really tricky. So what's been sort of built on then since... So the first person to notice this was, I guess, Brandon Carter, a famous paper in 1973. A number of physicists then started looking into more and more examples of this. More kept popping up. Paul Davis published a book called The Accidental Universe and published a big review paper in the early 1980s. His book was called, and I've just forgotten the name, so I'm looking behind me. I think it's called The Accidental Universe. Yeah, there it is, The Accidental Universe. The famous The Anthropic Cosmological Principle by John Barrow and Frank Tipler came out in 1986 with just Yeah, huge numbers of examples of the kind of things that the sort of disasters that happen when you start to change these numbers. And then as time goes on, they were sort of attacking these with pencil and paper models. As time goes on, various physicists, including myself and Geraint Loomis, who I wrote the book with, are now sort of attacking them to get more precise details, but with numerical models, with supercomputer simulations. So the short answer is because we can do theoretical physics is how we came to that conclusion. And the necessary conditions, we just look for it's not that we have a necessary conditions for life, is that if the best way to think of it is that we have sufficient conditions for not life. So a completely homogeneous universe where there's literally no structure whatsoever, or a universe that's expanded extremely quickly, so literally no two particles ever stick to each other, or universes where the entire periodic table disappears and you can't stick more than two particles together at all. Where actually disintegration is the norm rather than the possibility of building up structure as in our universe.
All right. And then we have another question from, this one comes from the Durfee. I think this would be a good one to get out of the way early on. The statement that the universe is fine-tuned for life requires a clear definition or a set of properties that are required to be alive. Otherwise, these fine-tuned parameters being leveraged will seem arbitrary. So what's your definition of life, and at what point is it life?
Well, as I was explaining, I don't need a definition of life. I just need sufficient conditions for not life. To be conservative about the sort of cases we're making. So if you're think about a big whiteboard with all the possible universes on them. Of course, it's much higher dimensional than a two-dimensional board, but that will do. If we wanted to totally map out where life will and won't turn up, then yes, I need a definition of life and I need to know what I'm talking about. However, if I just want to color in various regions as definitely no life here, then all I need is some sufficient conditions for things that are not alive. Now, all I can do is be very conservative about that, stay well away from any edge cases, any tough cases, any difficult borderline cases. So any questions like, oh, is a robot alive? Is a virus alive? Just don't touch fine tuning at all, because we can just stay well away from them. Could life be based on silicon? Just doesn't matter. It just doesn't matter to the sort of calculations that we're doing. So the fine tuning of the cosmological constant. The case there where we consider, okay, there's no life in this universe, is where literally every particle is just alone in a trillion light years of empty space. If you've got a definition of life where a single proton in empty space is alive, then I'd suggest that that's a ridiculous definition. We can stay safely away from any of those sorts of debates, and still there are very serious and important and surprising fine-tuning cases.
All right. So one question that I had was, one of the most common objections to fine-tuning is that it relies on a kind of survivorship bias, and that in reality it's not at all surprising that our universe's physical constants are life permitting, given that we're here to observe them in the first place. So how do you respond to objections like these?
Well, you've got to have, so the way I think of that is the way an astronomer's going to think of it in terms of a selection effect. So one of the things you need to keep a handle on when you're sort of any sort of scientist really is that there's a population of things out there that you want to know about in the universe. Let's say galaxies, just for one example, but it could be, ants or whatever. So that's the population, all the galaxies. Whenever you do a set of observations, very often you won't have the whole population at hand. All you'll have is a sample drawn from the population. So suppose you go with your telescope, you point it in a particular direction in the night sky, and you stare at that little, say, squared degree of space in the night sky, and look at all the galaxies you can find in there. Well, clearly you're not looking at every galaxy. First of all, you're looking at the ones that are only in that 1 square degree of space. And also, you're only seeing ever the brightest ones above a certain brightness limit, which depends on your telescope and how long you look for. And that limit also changes with distance. The further away something is, the brighter it needs to be in order to turn up in your survey. So the thing that connects a population to a sample drawn from the population is the selection process. And so you have to be careful about whether the effect that you think you're seeing in your data is due to the selection effect or whether it's really in the population itself. So suppose you start to notice that the further away a galaxy is, the faster the stars in the center of that galaxy appear to be moving and orbiting around. And you might think, oh, that's interesting. The further away something is, the faster the stars move. Oh, but hang on. The speed that those stars are moving depends on how much mass is there. How much mass is there determines how many stars form. How many stars form determines how bright this thing is. And so it determines whether it turns up in my sample or not. And so actually, in that case, it's a selection effect. It's not an effect in the population. Moving back to fine-tuning, a selection effect only does work for you if you actually have a population. A selection effect on its own can't do anything for you. So if you want to say that the properties of our universe are determined by a selection effect, where our universe is the sample, what's the population? And it can't just be a population of possible other universes. That's not going to do it for you. It must be a population of other actual universes. So that is, in other words, it's just the multiverse proposition again. Otherwise, the selection effect doesn't do anything. So to put that another way, answering the question, how do I want to say this? If I ask the question, why does a life-permitting universe exist at all? It can't be. The answer can't be because we're here. That just doesn't work at all. That would be like saying, why do bright galaxies exist at all? And the answer is because otherwise we wouldn't see them in our surveys. That's the wrong answer. If you say, given a population of galaxies, why do we see the brightest ones? And the answer then is because those are the ones that turn up in our surveys. That's fine, but you've got to have a population there. So I don't think a selection effect on its own can explain things if we're looking at that deepest question of why is physical reality the way it is. So to put it another way, it could have been the case that reality just had no observers in it at all. Modulo, if you've got some weird ideas about quantum mechanics and all that sort of stuff, but never mind that. You could have a universe which just doesn't have observers in it, doesn't have life in it. Why isn't the universe one of those universes, which seem to be much more probable? Why is it our type of universe rather than one of those types of universes? And the answer can't be in any straightforward way, well, because we're here. That just doesn't work. You have to have a population before a selection effect does anything.
So another question I had was some people want to explain away any apparent fine-tuning by invoking a multiverse hypothesis and saying, well, maybe there are an infinite number of discrete universes with every possible combination of physical constants, and we just happen to find ourselves in one of the ones that are life-permitting. Do you think there's any plausibility to this explanation? And if it did turn out to be the case that we were in fact just inhabiting some tiny slice of an infinite multiverse, would this, in your view, pose a serious issue for fine-tuning arguments?
Okay, so that's kind of the $1 million question here. So I always feel like I've talked too much on these things, but this one's going to go for a bit. So strap in. There has been criticism of the idea that there's a multiverse from some very eminent cosmologists. So Joe Silk and George Ellis are two massive names in the history, in sort of modern cosmology, sort of pioneers of the field. Silk is at Oxford, and Ellis was a student of Hawking, now in South Africa. They're criticizing the idea, saying basically it's not scientific because you can't test it in any meaningful way. I actually don't subscribe to that. I think it's a valid scientific theory because, one, it's proposing a certain way that physical reality might be for all we know, and that's enough to get you started. That's enough to at least warrant having another look at the theory. And secondly, there is something that a theory like that is supposed to predict that the current theories that we have, the current standard models, don't predict. And those things are precisely the values of the fundamental constants. To have a proper have a proper multiverse model, it should be the case that, I mean, you're proposing a population of universes. That's what your model is. If you have a properly well worked out, well formulated multiverse theory, you should be able to ask it questions like this. Okay, for a typical observer who turns up somewhere in your multiverse, where are they relative to the universe? Are they on a rocky planet, or are they somehow in some other environment around the universe that we see, or is there some completely unknown environment? You could ask a question like, what is the value of the cosmological constant in the universe that they inhabit, assuming that it changes from universe to universe? You should be able to do all of that stuff. At the moment, we don't really have. Well, yeah, I'd say we don't, and I can defend this, but it's arguable. I defend the idea that we don't really have a theory that does that in any convincing way. So in particular, we've written papers doing supercomputer simulations of galaxy formation, varying the cosmological constant. What we then wanted to do was fold that into a model for the multiverse to then get some predictions out. The problem is there are various steps where everything's sort of put in by hand rather than coming naturally out of a model. The reason that's relevant is I see fine-tuning as of the constants as trying to answer the following question. What other way could the universe have been? And if we survey all those other ways, is there anything particularly interesting or weird or unusual or noteworthy about this universe, or is this universe just some boring, typical, run-of-the-mill universe? So people say this about, we're, the Earth, we're just third rock from the sun around a typical old star in the backwaters of some typical galaxy, and there's hundreds of billions of stars in each of the hundreds of billions of galaxies, right? That's a way of saying, look, Earth, we're not that special. Well, what about the universe as a whole? Is there anything about that compared to the way the universe could have been that seems special? A way that we could sort of systematically look at other universes is by changing the fundamental constants in the standard model. What the multiverse does is it has to replace the standard models. So in this, I'm talking the standard model of particle physics, where you have parameters like the mass of the electron and the strength of the electromagnetic force and stuff like that, and the standard model of cosmology, where you have the cosmological constant, the other parameters of standard cosmology, depending on how you do it. Parameters like the density of matter and that sort of stuff. In those models, those models are just models of our universe, so they aren't multiverse models. And in particular, because in those equations the constants are, as the name suggests, constants, they aren't multiverse models. You have to replace those with a deeper theory in which the constants are actually not constant. They are something that can vary from place to place around the universe. What that means is, if you then do that, if you replace the standard models with the multiverse model, then our quest to go and ask what could physical reality have been like, if we're looking to the deepest level of laws that we have, you've just now shifted them down to whatever the laws of the multiverse are. So the multiverse then explaining the laws as we see it doesn't necessarily address fine-tuning, because if we look at this bigger project of how could the universe have turned out, we want to go and ask the deepest laws we have, and those are now the laws of the multiverse, and we want to go ask it, okay, what sort of multiverse could there have been, as our best way of getting a handle on how could physical reality have turned out. So it doesn't necessarily address fine-tuning, and at the moment I don't think we have the models to even start to answer the question of what would a typical multiverse be like. And I promised I'd waffle on, and I did.
Okay, well, that was a very thorough answer. I appreciate that. So my last question here is fine-tuning proponents tend to talk about life permitting or intelligent life permitting conditions as if it's a binary concept. So a universe could be life permitting or not, intelligent life permitting or not, and so forth. But it seems to be more like a continuum. That is to say, some physical conditions will allow for the formation of more complex forms of life than other physical conditions. So with this in mind, how do we know that the physical conditions of our universe are really ideal in this respect? And if it turns out that they're not ideal, and these physical conditions put a sort of cap on the complexity of life in our universe, while different physical conditions might allow for even more complex life to form, would this provide evidence against the theism hypothesis?
Okay, so actually, Geraint and I should say, the book I published on this with Geraint Lewis, A Fortunate Universe, he's an atheist. So if you want to read something which was written by a theist and an atheist about the stuff that they both agree on in the science, then the book is good for that. It's in the last chapter, chapter 8, where we actually sort of just start discussing multiverse versus theism, all that sort of stuff. Geraint and I just released we also have a YouTube channel called Alas, Lewis and Barnes. We just had a video on that today if you want to hear more about that. But it's the important point is it's no part of fine-tuning at all to say that this universe is optimal in any sense. It's not that we're at the top. With the we're at the top. The thing we explain in the video is, in order to work out whether there are ways to make a more life-permitting universe, starting from its fundamental equations, not just going, well, what if that river over there was full of orange juice or something, but actually starting from like the bottom, as we're trying to do. In order to do that, we have to do the opposite of the thing I was saying before. Fine-tuning sort of gets interesting when the universe gets a whole lot more simple, because then we know what would happen in that universe. To work out whether there's a more life-emitting universe, that universe would be at least as complex, if not more complex than our universe, it would seem. Because life is a complicated kind of process. That's sort of a minimum thing you'd want to say about life. So it's no part of fine-tuning that we're at the peak. You're right. If we could map things out in great detail, again, we need a proper, very precise definition of life, or at least, a couple of definitions that cover, you could just take like the union of all the definitions or something like that. We need a very precise definition, and then we have all those possibilities on the whiteboard again, and we go looking around at all of those. If we could sort of trace those out in detail, you might even think about putting like a suitability number on that, and then it becomes kind of a landscape where the peaks of the landscape are where life is particularly likely to turn up, and other parts it's less. That's a much more complicated thing to attempt. What fine-tuning points out is that even at the level of okay, that universe is so simple, there's nothing going on there that's interesting, we still know enough about that whiteboard of possibilities to know that there are vast parts of it, the vast majority of it, in fact, where you don't have anything like the complexity needed for life, because you lack the most basic things, like two particles in the universe will be able to stick together and not immediately fall apart. So yeah, I'd love to simulate all of the possible universes in all of their detail and see whether anything waves back at me. But in the absence of that, what fine-tuning is onto is just that we can look for drastic steps towards simplicity where we really can solve what the universe is capable of. And when we map those out, we find that an awful lot of the possibilities are really boring, even if there's some sort of interesting landscape on the rest of it.
Okay. So the next question comes from Kaspersky, and they ask, is God really an explanation here? It seems God could have created a world with no life at all. It's a matter of contingency that God creates a life-permitting world, so what is it exactly that positing a God explains? It seems no less virtuous than just saying the laws are metaphysically necessary, since God easily could have created non-life-permitting worlds.
Okay, there's a couple of things there. First of all, this is well, at least the way it's usually presented. So, Richard Swinburne, Robin Collins, myself, a bunch of other people. It's a probabilistic argument. So mere possibilities aren't enough. You're sort of weighing different probabilities, and so to just give an illustration of this point, this is not an analogy for the fine-tuning argument. This is an illustration. Suppose you are playing poker, and as usual, you take it in turns dealing the cards, and you notice that one of the other players, Fred, whenever he deals the cards, he deals himself a royal flush. Now, he proclaims his innocence, but this happens 5 times in a row, and the chances of that are some stupendously small number. And Fred, you accuse Fred of cheating on the basis of the 5 royal flushes in a row. I think it's something like 1 chance in 10 to the 50, whatever. And he says, well, think about all the uncertainties about that claim. You don't know how I'm doing it, if I'm doing it. Your accusation, the hypothesis you're putting forward, doesn't have any details about how I did it. You don't have any a priori reason to think that I'm the sort of person who would do this or would be able to do it. You don't know why I would choose 5 royal flushes in a row rather than, a couple of royal flushes and then maybe a straight flush and 4 aces and a 4, the sort of hands that basically win poker every time, but not always, right? There's all those uncertainties around. All of those in this circumstance would just get immediately swamped by the improbability of fairly dealing yourself 5 royal flushes in a row. So I think at the very worst case scenario, the question is, these uncertainties about what God would do and whether they do it this way or that way, are they the kind of things that are the same level of improbability as getting a naturalistic universe that supports life, given what we know about fine-tuning? Or are they comparable to those, or do they just get completely swamped by them? I would suggest that given the extreme improbability that we seem to get, and I've got papers that flesh all of that out if you want to have a closer look, that the sort of uncertainties about what God might or might not do just don't matter very much. The reason for that's quite an important one within probability theory, or the sort of reason for that sort of explanation. So let me give another, again, illustration, not an analogy. Suppose, suppose you go to a nice little country bowling club one evening. You're on holidays and you pop in there for a meal, and then they have their some sort of local lottery that they do to raise some money, and everyone basically picks numbers that are the same as picking a number between 1 and 1 trillion. And so you look around and there's sort of 10 other people in the room playing this game, and you think, well, no one's going to win this thing. This is going to jackpot till eternity. And then lo and behold, the numbers come up, and one of the other people in the room has won the prize. Their number between 1 and 1 trillion has actually turned up. Their sort of 10, 11-digit number actually turned up. Now, in that case, you have a good prima facie case that some sort of cheating has gone on. Right? It's probabilistic argument. It's not certain, but the fact that 10 people played a game where there was 1 in a trillion chance of winning and one of them did suggests that not everyone was playing the game fairly. Now, the reason why you can do that, so the person who wins might object, oh, look, whoever won, you could still say that person must have cheated. And so, that you could just make that accusation about whoever won. Well, what's going on here for that explanation to work is that the probability space itself has been transformed. So before, the probability of someone winning, the space of possibilities was those trillion possible tickets to the lottery, right? And so that's the size of the space. Okay. Once you then move over to the space of people who could have rigged this particular lottery, now there's the probability that anyone would rig it, and you don't really know what that is, but it doesn't seem ludicrously unlikely. And then given that someone rigged it, the probability that that particular person, right, who won the lottery, Fred, before the lottery, you didn't have any reason to suspect Fred, right? So there's sort of two improbabilities in there, but the difference is when you think about the set of people who could have rigged the lottery, there's now only 10 of them. And it's those 10 that you're uncertain about, sort of not including yourself, obviously. It's that change from 1 in a trillion tickets under the it's a fair lottery hypothesis to now 1 in 10 people under the someone rigged this lottery hypothesis. That's what makes all the difference and why those numbers turn out, I'd suggest, in favor of the someone rigged the lottery. And if you don't like that, then make it 1 in a trillion trillion or 1 in a trillion trillion trillion. What's happening with the God hypothesis is a change between before, in naturalism, as best we can sort of put together what would it be like if you just chose a universe with no deeper reason. We model that state of uncertainty by choosing a set of constants at random in the deepest laws that we know as a way of trying to get a handle on that. When you go over to the God hypothesis, it's a transformation from picking a set of constants at random to, at worst, you don't know what God's reason for making the universe is, or whether God would want to make one at all, which is the sort of the corresponding bit to the you don't know whether someone would rig it at all, and you don't know who would rig it. So again, worst case scenario, the idea that God would make a universe in which it had consistent laws so that the inhabitants of that universe would interact with each other consistently, via the external world around them. So if I want to have a moral effect on someone, it's through the world around them. And that the idea that God would want to make a universe with embodied conscious agents. Now we're thinking about the problem in those terms, and that's a completely different set of terms to think about, why physical reality is this way rather than some other way. So it's on that basis that the problem gets transformed. And I think it's suppose the probability of the cosmological constant and a couple of other things, suppose it's some ridiculously small number for the sake of argument, like 10 to the 100, 1 chance in 10 to the power of 100. To make the probability of, the same outcome on theism to be similar to that, comparable to that, which is what matters, not whether it's 1 or a half or something, but whether it's comparable to 1 chance in a 10 to the 100, you'd have to have a set of 10 to the power of 100 possible reasons why God could create the universe, which are comparable in plausibility to the idea that God would create a universe with moral agents in it. And I don't think that that's remotely plausible.
We had another question from the Durfee. If theism is true, wouldn't we expect more consistency among God's revelations? Meaning the Christian God asserts his existence through revelation, yet these revelations aren't consistently observed. There are other gods, no revelations, etc. It does not make sense that an all-powerful being would fall short like this. How do you respond to this?
Yeah, not really a fine-tuning question.
Just a more general.
Yeah, I mean, what do you mean the revelations are inconsistent? I mean, if you mean that the Bible is inconsistent with the Quran, then deal with it. Pick one, right? Go look into the evidence behind them both. I mean, the answer might be neither, but the fact that it's not both doesn't mean it's not either of them. And if what you mean is that there are inconsistencies within particular claimed revelations, then we'd need to go through those case by case. I mean, yeah, there's no sort of general. You can't answer a question like that in general. You just have to look at a particular case and see what you think.
All right, so I think Charming Chalmers wanted to follow up on that. Here, I invited you to speak if you want to come to the stage.
My question is, if the God hypothesis makes it more probable that the universe would be fine-tuned because God has certain reasons that makes it more probable that he would want to create a universe with physical constants that are conducive to life, or at least make it possible. Well, what would explain the existence of those reasons, right? So, in other words, what would explain the fine tuning of God's reasons?
Well, I don't think that. Yeah, that's a good way to point it. Actually, I don't think they would need to be fine tuned to the same degree that the constants need to be fine tuned on naturalism. It's a comparison thing here. I just don't think there's. So if I was reading a paper the other day which was trying to suggest that on naturalism it's highly unlikely that the cosmological constant has some particular value where you specify it to 10 decimal places, and the person was trying to say, well, on all we know for theism, God could also have some sort of preference for the cosmological constant having that particular value to 10 decimal places. And so, therefore, theism and naturalism on this count are just as bad as each other, so to speak. There's a whole lot of possibilities and we don't know. And I think that's just highly implausible. That just doesn't. I mean, all I need God to want to do is, God. My idea of God is that God is perfectly good, and a person, or more like a person than anything else we know in our experience. More like a person than a God. I'm happy for that to be analogous language or whatever. I don't, but it all I need then is that God has the idea. Hey, what if I made some more persons who could experience what love is and may have a real, genuine moral life with moral decisions and experience the good of moral goodness. And I mean, that just does not seem to be particularly fine-tuned in any way. There's no massive set of possibilities, and I'm just pulling that one out of nowhere. Like that seems just not that implausible. I mean, it doesn't have to be probable. It doesn't have to be likely. It just needs to be not ridiculously unlikely, and that's all the claim I think I have to make there.
I see. Thank you.
All right. Well, thank you for your questions, Charming Chalmers. So we'll now move on to a question from Detroyer. So Detroyer asks, if someone were to propose a design hypothesis on which the designer's creative dispositions are not biased towards life or life-permitting conditions, then this hypothesis wouldn't predict life-permitting parameters very well at all. Of course, we needn't judge the plausibility of theism based only on those sorts of hypotheses. Why not say the same of atheistic hypotheses and allow into analysis atheistic models which predict or at least make plausible life-permitting conditions?
Yeah, so that is a possibility. It's just the typical picture that we've gotten from naturalists and atheists over the last whatever, when was Hume? 1750, at least, is that there's a quote from Bertrand Russell, basically saying, look, everything we see around us is purely the result of accidental collocations of atoms. It's that picture of the universe as just any old place. There's nothing special about it. So that was the response to the design argument. That, not even the design argument, just the design intuition of, like, just look at the world. It's an astounding place. If you went into a laboratory with all the best technology you had and walked out any amount of time later, even a billion years later, and you had constructed a hummingbird, that would be amazing. That would be incredible. It would seem to take, a whole lot of, design and thought and effort to do that. So that's the design intuition. That's not saying anything about how it came about that there was a hummingbird. It's no evolution in and of itself isn't a complete answer to that, unless ours is the sort of universe in which evolution is the kind of thing that will just happen. Universes are the kind of thing where evolution will just happen, in any old universe. What fine-tuning does is pull the rug out of that, out from under that escape from the design argument. So biology, Dawkins has this quote that biology is the study of systems that look like they've been designed. There's some quote like that. I think it's the start of, I've got it behind me, Blind Watchmaker. He then says physics is the study of simple systems that don't tempt us to invoke design. But the problem is, what the fine tuning shows is actually no. If you look at the deepest level, you see the same sorts of, this is an amazing and rare universe. This arrangement of stuff we have around us has some amazing and rare properties. In the same way that, again, Dawkins says, if you throw cells together at random for as long as you like, you'll never make anything that flies. Whereas if you in the hummingbird sense, whereas the fact that then something does fly in our universe, for Dawkins says that evolution is not a random process, right? And he's right about that. That's all fine. But if that's the approach then of what if I throw stuff together at random, if we then need to move that question back to the universe as a whole, to say, if I throw a universe together at random, will it have the necessary conditions for evolution to start up at all, so that evolution could then make hummingbirds? And the answer from fine tuning is just no. That's not the sort of thing a typical universe will do. If that didn't quite answer the question, I may have wandered a bit too far away. Then feel free to come back around.
Well, Detroit, you can certainly let us know in chat if you want to follow up in BC or something. But for now, I will move on to the next question. So, Gizmo wanted to know if you're familiar with the work of Karl Friston. He says Friston defines life as that which has a tendency to perform or seem to perform inference or hill climbing towards the preservation of its own structural and functional integrity in a way that draws a boundary between the living organism and its environment. So he essentially just wanted to know if you're familiar with the work of this guy, Karl Friston.
No, I'm not, but that's an interesting definition, actually. Karl Friston, I'll look that up.
Friston.
Yeah. Does a virus fail to do that because it has to sort of latch onto a host?
I'm not sure.
I'm taking
BC and clarify. He can. Let me know if you want to do that. He said that Karl Friston was asked this on his Lex Friedman podcast 99. He's still typing, so I don't know if he's able to chat or not. See, I believe he said it didn't count as life, but I don't recall. Virologists are divided.
Yeah, that's one of so the interesting sort of borderline cases are viruses, because they don't replicate in and of themselves. They sort of attach to something else to replicate or whatever. I'm an astrophysicist. This is not my field. And things like, sufficiently advanced computer, would that be alive? Those sorts of things. Anyway, interesting.
Okay.
I'm going to look that up.
All right, so thanks for the question, Gizmo. Of course, if you want to follow up or ask anything else, let us know in the chat. But we'll move on to another question from Detroyer. He asks, does the designer hypothesis make any interesting novel predictions? Of course, it predicts things for which the hypothesis was originally intended to explain, for example, that there is a world, life, and so on, and things entailed by these predictions, for example, that there would be conditions that permit life. But can we use the hypothesis to make predictions about things it wasn't originally intended to explain, or that aren't entailed by things it was originally intended to explain?
So the question then it's I see prediction as being a subset of explanation. That's my approach to these things. There's a problem. I don't think it's I think it's a pseudo problem, but there's a problem discussed in the philosophy of science literature about whether if I have some data that everyone knows and then a theory comes along that explains the data after the data is known, does that have any value? And I think the answer to that is unquestionably yes, because there are clear cases in the history of science where we have exactly that, and there's no question that it's legitimate. So, for example, as we watch the planets go around in the solar system, it becomes clear that Mercury isn't exactly where Newton's theory of gravity says it should be. This is called the perihelion shift of Mercury. It was known especially towards the end of the 1800s, quite widely known. Various attempts to explain it had failed. If there was a planet between Mercury and the Sun, that would have explained it, but attempts to find such a planet continually failed until in 1915, Albert Einstein presents his general theory of relativity, uses it then to predict what the orbit of Mercury would be, and lo and behold, the difference is perfectly accounted for. This famous 42 seconds of arc, 42 minutes of arc, seconds per century. What is it? Every century, it's out of place by like this enormously tiny amount. I think it's 43 arc minutes. So less than a degree. But Einstein's theory nails that. Now, the data came first, the theory came second, but the theory explains the data so well and so naturally that you shouldn't care about that. You should double check whether there's anything Einstein could have done to rig his theory in favor of explaining the evidence in a way that is unnatural or itself fine-tuned. So if behind the scenes inside of general relativity, there was some free parameter, and Einstein, knowing that it needed to predict this 43 arc minutes per century, I'm just going to Google that. That's annoying me. I can't remember which one it is. Perihelion shift of Mercury. I should know this backwards. Anyway, if there's a free parameter that Einstein can with one eye on what he's supposed to be explaining here, can have that. Can keep one eye on that. So hang on, it's I'm the only person who cares about this, but I don't. Anyway, it's arc seconds. Okay. 43 arc seconds, 42 arc seconds per century. So 360 degrees in the full circle, 60 minutes in a degree. So a 60th of a degree is an arc minute, and a 60th of an arc minute is an arc second. So it's 43 arc seconds per century. So they knew about that very well, sort of accounted for. So I think predictions are nice because what they tell us is there definitely can't be some sneaky way behind the scenes that the theorist could have used to predict the data if he or she didn't have the data already. With Einstein, we can't have that assurance. We have to go and sort of check ourselves and actually understand the structure of the theory and actually look at what is free parameters and what aren't free parameters. And with Einstein's general theory of relativity, if you know the theory, it is absolutely abundantly clear that there's no way Einstein could have tweaked things behind the scenes. There's just no free parameters back there. The only decisions he's sort of making are very broad decisions. There's nothing with the sort of fine detail you could get to dial in the number 43 arc seconds per century. And so in that case, it's as good as a prediction. So what I want to say is, are there predictions of theism? I don't want to push that. I don't think there are particularly. You might want to say that where there are, you might guess that where there are parameters that seem irrelevant to life, that maybe we'll find out some way that they're relevant to life, but even that's not a particularly secure parameter. But the other side of this is that if naturalism doesn't produce any predictions either, then it's just a washout between the two. And I'd say that. So I was at a summer school for the philosophy of cosmology. I got invited along to speak, and it was great. And Sean Carroll was in the front row of the audience, which was terrifying. Just uber smart dude. And so he put this question to me of if you think this idea of God can predict something, then why don't you predict the mass of the Higgs boson, which at that point hadn't actually been. This was 2013. When was the Higgs discovered? A couple of years later, I think. Anyway, in particular, so I just presented Richard Swinburne's version of the article. I think you can find this online if you look hard enough. If you really think you know the mind of God, then predict the value of the Higgs boson. And a complete answer to that question would be, well, I can't possibly do any worse than naturalism, which has no idea what the mass of the Higgs boson is either, other than what we get from our experiments. If all theism can say is, I don't know either, we're just in the same boat, then that's not a way to decide between the two. So the fact that God explains some things, seemingly, I'll leave that up to you. I think it does, but it's up to you. The fact that God seemingly explains some things and leaves other things as just still in the I don't know basket, I think leaves it in it can only be doing better than naturalism, which leaves everything in the I don't know what this constant would be basket.
All right. Well, that was a very very thorough answer. So Troy had one more question. He says, "Are you familiar with Nielsen Hababu's argument in divine fine-tuning versus electrons in love? According to him, if the designer could in principle make just about anything alive in the relevant sense, then the design hypothesis does not predict fine-tuning. If the designer could ensoul, say, electrons floating in the void, and perhaps imbue them with other complex properties, and that satisfies his creative desires, then why would we expect, on the design hypothesis, that the physical parameters allow for complex chemistry, let alone anything like biological life?"
So again, saying that on some hypothesis we don't know, we can't decide between this or that, does not mean it's not the best hypothesis. That doesn't mean that the probability of a life-permitting universe, given a fine-tuned life-permitting universe, given theism, suddenly drops to zero, just because it seems like that probability is the same as the probability of a life-permitting but non-fine-tuned universe on theism, the sort of electrons in love scenario. Even in a worst-case scenario, those look like they're two possibilities that God could go with. All that's doing to our probabilities is cutting them in half, which when there's 10 to the 100 on the table, on the other side of the scales, I'll take a half, who cares? It just doesn't affect the probabilities at all. So you have some very, I think, detailed and interesting arguments along these lines from Richard Swinburne in his book, The Existence of God, which says, okay, suppose, let's take the basic thing that we're going to assume here, which is God wants to make embodied moral agents. I think that's Robin Collins's term, but close enough to what Swinburne's trying to say. Okay, if you have a moral agent, there must be, if that term's going to make any sense, there must be a part of the universe which is of reality, which is under the control of that agent. Okay, you can't make a moral decision and have it have moral consequences if you don't have any causal powers. Like if you just sit there thinking, I mean, I suppose you could think bad thoughts, but that's the most, you wouldn't do anything to anyone else. So that's kind of the best, or what you could either think good thoughts or bad thoughts. That's a fairly limited moral life. Well, okay. In that case, if there's more than one moral agent and they can affect each other, then they must have the bit of the universe which is under their control And there also must be some way that they can influence each other by something which is outside of both of them. So, for example, there must be some sort of medium between them by which they influence each other in one way or another. And if it's going to be a moral decision, there has to be some sort of predictable consequences. It has to be the case that I can make the moral choice to build a house rather than building a bomb. So it's good to build a house for someone, and it's bad to build a bomb and blow someone up. But in order to do that, the stuff that I'm influencing around me as a moral agent has to have predictable properties. If bricks just spontaneously exploded every now and then every potential house could be a bomb. I couldn't do anything. So what Swinburne points out is, okay, that's a very, very basic scenario of, if not the necessary conditions for having an embodied moral agent, at least a very reasonable set of conditions for an embodied moral agent. And then now just label the bits that we've discovered. The bit of reality that is under my control is my body, or at least, yeah. Well, let's say my body, that'll do. The bit of the unit of reality that's under someone else's control is their body. The medium between us that we can influence, but the other person can influence as well, would just be the physical world. And the fact that it's predictable would just be the laws of nature or the laws of physics. And when you put it together that way, it just doesn't seem that unlikely to me that God would do it that way. And I don't even need it to be likely. I just need it to be not ridiculously unlikely, as usual. On the other hand, if you had something like Electrons in Love, you would have a universe in which you would have life forms or life forms of some sort, but either the stuff around them behaves in predictable ways, in which case you've basically got fine-tuning again, or it behave in unpredictable ways, in which case you haven't really given your embodied moral agents any sort of freedom that would be useful to them or morally relevant. So, as much as I understand that argument, that's where I think it falls short. It's raising a possibility, but one more possibility at worst just cuts all of our probabilities in half, unless there's some reason to think that God would definitely do it that way. Not that that he could, or that he's as likely to do it that way, but he would definitely go that way rather than the fine-tuned universe.
Right. So we have a question from Yubo that's on a little bit of a different topic. I'm not sure how much you get into theology, but he has kind of a theological question here. If you don't have a good answer for it, then you can just skip it after you hear it. But he asks, as a Christian, you'll no doubt be aware of the tensions between Hamartiology, theology of sin, and the scientific consensus on the origin of the universe. Many theologians argue that the fall must either be allegorized, that is, merely introduced spiritual death and not physical death, or done away with entirely for origin science to hold, which they deem sufficient reason to reject its findings altogether. I know that you're a cosmologist and not a theologian, but I'm still curious to know if and how you would address an argument along those lines.
Yeah, you're not tapping any area of my expertise here. I don't think cosmology actually helps too much there. Very, very briefly, I don't think Genesis is giving us any sort of timeline. I don't think that's the point of Genesis at all. I don't think that's why it was written, not just the way we interpret it today. I think it's wonderful and profound, but not doing that thing. And so I don't think there's an issue about when sin and death come into the equation. I think what matters is when moral evil comes into the world, and I think that needs embodied conscious agents as a sufficient level of intelligence, like us. So the things that happened before them wouldn't be the result of moral evil, and I guess wouldn't be then evil in that sort of sense. Yeah, with a question like that, there's a whole bunch of questions in Christianity where I think, okay, I could spend like, a month just reading about that. And at the end of it, I suspect I would go, well, I don't know, there's a bunch of things it could be. It's a bit like the Shroud of Turin. There's that piece of cloth which is supposed to be the face cloth across the body of Jesus, and it's supposed to be evidence of Jesus's body. And there's so much debate about that. I just feel like I've never really looked into it, and if I did, I'd spend like a whole month, and at the end of the month, I'd be like, I don't know, we don't know, no one knows. And so that maybe that's wrong, but that impression just dissuades me from digging into that any deeper than I have, I'm afraid. So that's why I'm not a theologian.
All right, that's fine. So we have a question actually on the topic of physics here from KQ. They ask, what are your thoughts on cosmic inflation and the problems it solves that we get from the singularity, magnetic dipoles, homogeneity, isotropy, displacement of the cosmic microwave background, and whether the universe had an absolute beginning or whether it's eternal? I guess it's kind of a two-part question, but did you get all that?
Yeah, roughly. So yeah, inflation. So here's the idea: the standard model of cosmology. So you have Einstein's theory of general relativity. You tell it what the universe is made of, and that it's basically smooth and the same everywhere. And then it tells you the history of the universe. So the way the density and temperature of the universe has changed with time, as everything sort of as we go back into the past gets closer together. What that predicts, and unequivocally predicts, is that there was a time in the past when basically the distance between anything in the universe was zero. This is what we call the singularity. It's a very, very weird thing. Even within that theory, there's a couple it does a very good job of explaining a whole lot about the universe. But when we have a closer look at the initial conditions of the universe, not at exactly t equals 0, but maybe just slightly after that, after the Big Bang, a tiny fraction of a second after then, there's some weird things about that don't seem particularly, don't seem particularly natural, although that's a very loaded word in physics. So there's a standard textbook arguments that say, if the universe didn't have a very particular relationship between its rate of expansion and its density, at that point we'd see a very different universe to the one that we see now. It seems very unlikely that the universe would have been completely smooth back then, given it enough time to sort of smooth out any initial, lumps and bumps that the universe might have been born with. There's a period in the universe where some of our theories about the way matter works predict the existence of a whole bunch of particles known as magnetic monopoles. So, magnets have a north and a south pole, but if you cut a magnet in half, what you don't get is a north pole on one piece and a south pole on the other. What you get is two little magnets, each with its own north and south pole. But there's a prediction that there could, in fact, be a thing which would just be a magnetic north pole called a magnetic monopole. These have never turned up in an experiment, but there were some theories that predicted that they should be all over the place. So that's the situation. It turns out that there's a tweak to the standard model that would solve seemingly a bunch of these problems for what looks like only a small amount of input. If early on in the history of the universe, very early on, there was a brief period in time where the universe expanded very quickly, and by that I mean exponentially, so it sort of doubles in time every very, very small period of time. Then that would actually solve a whole bunch of these problems, in a reasonable way. Now, there's a couple of things to say about that. First of all, it's really interesting and quite striking, which is why the idea caught on pretty quickly, that such a simple idea could do it. Number two, the problem is it's not really a physical theory. It's one effect producing another effect. It's quick expansion producing a uniform universe that's expanding at just the right rate and doesn't have any monopoles in it. what we would really want, so that's expansion doing that stuff. What we need is what's the stuff the universe is made of that causes the expansion, that causes the solution to those other problems. And that is generically called the inflaton, the thing that causes inflation. But there's 1,000 different models for what the inflaton might be. So it's not that we have no ideas, we have too many ideas, and not much of an idea about how to test them, except for some recent stuff in the cosmic microwave background, maybe. So that's the sort of the status of the theory at the moment. In terms of fine tuning, just to get back to that, it's not clear to me that it solves any fine tuning problems more than just that it moves them back a level. It's very hard to know whether the inflaton itself is fine tuned if you don't know what the inflaton is. I don't think it solves the singularity problem in and of itself. So there's something called the Bode-Guth-Vilenkin theorem, which almost says the opposite, that if you have a classical space-time, which is a space-time theorem, it's a space-time theorem, and it is on average expanding for its entire life, then there must be a singularity at some point in the past. So inflation in and of itself can't make you an infinitely old universe. So you would have to sort of attach inflation to some other idea about that. So the question of whether the universe has a finite age or not is a really interesting one. What we have, so the first thing to say is obviously no observations directly answer that question. So that's a distinction that needs to be made, I think, a bit more often in science, actually. Obviously, we don't point our telescope at something and that we just look through it and then we get the answer to that question. If something's going to tell us the answer to that question, when we want to know the answer to that question, it's going to have to be a theory, a good old-fashioned theory, which presents a complete model for the universe, including about whether it has a beginning or not. And so the question then is, which theory should we ask about whether there's a beginning of the universe or not? Which complete model, complete picture of the way the universe is set up should we ask as to whether the universe has a beginning or not? And the answer to that is, unfortunately, we don't have any good theories that could go all the way back to the beginning, because famously, we don't know how to combine quantum mechanics with the theory of gravity in a way that would allow us to do that. However, having said that, there are an awful lot of theories that don't combine those two things, which are just space-time theories like general relativity, and even very general, even the Bode-Guth-Vilenkin theorem, which is still a classical space-time theorem, but it's broader than general relativity. And if you ask those theories on quite general grounds, the answer is yes, the universe does have a beginning. On the other hand, it's not clear what a beginning would look like in a quantum mechanical, sort of space-time. So that's I think there are very interesting clues that are pointing in the direction of a beginning, but we can't quite get all the way there to work out whether there is a beginning or not.
So we have next a question from Doggo Slayer 56, who asks, "Hi, Dr. Barnes. One of your responses to the multiverse objection is that we're more likely to be Boltzmann brains. How would you reply to the naturalist that bites the bullet and accepts that they're a Boltzmann brain?"
Why would they bother saying that out loud? Who do they think they're talking to? Yeah. Let me pull that apart in a bit more detail. So I think there's almost sort of two Boltzmann brain problems. So I talk about this in the book. One of them is a sort of an analogy to the brain in a vat thought experiment. Am I just a brain in a vat thinking that I'm talking to people and touching a computer and all that sort of stuff? So it's kind of, am I in the Matrix? And there is that version of the Boltzmann brain problem. If you have a cosmology in which that sort of thing could turn up at random, just via a fluctuation, right? A sort of brain in a vat style situation. The worry about that is, in certain cosmologies, it could be the case that making a brain in a vat that is having an experience of a massive universe that is, billions of light years across, it might be easier to make the brain in the vat than it is to make the universe that the brain in the vat thinks it's in which case brains in vats would be more likely than big universes, and in which case, all our observations are in fact fake. There's that the other one is, even in that sort of scenario, if you looked around not just at all the things that think they're observing the universe, but the things that are actually observing the universe accurately in some sort of sense, the way we think we are in some sort of sense. There's definitely a bird out there, I can see it. If you constrict yourself not to just any possible observer, but those observers, the observers who accurately observe the universe, in a scenario in which you can make those sort of things at random, it would still be the case that you're more likely to accurately observe that you're in a small pocket of order surrounded by chaos than that you're in a large pocket of order where if there's any chaos around, it's so far away that we can't see it. So that's us in the second one. So even if we just restrict ourselves to that second case, the Boltzmann brain thing says that you can't then bite that bullet, because that hypothesis is disproven by the fact that we, if you think that we accurately observe that we're in a big universe. So if you distinguish those two cases, which isn't done enough, now I'm talking about this, I'm wondering whether I should write a paper on it. So I think you can bite the bullet on the first one if you want to. I don't know what the point of that would be, but feel free. But on the second one, I don't think you can, because if we just restrict our attention to observers who pop up who actually accurately observe the universe, we're not typical of those on a random Boltzmann brain producing style of multiverse. So I think the real hope for the naturalist is that you won't have a Boltzmann brain producing multiverse.
All right, so next we have a question from Jack. This one's kind of long-winded because he's asking for your response to a passage from the Internet Encyclopedia of Philosophy page on design arguments. So, passage reads, Schlesinger's fine-tuning argument also appears vulnerable to the same criticism as the other versions of the design argument. See Hima 2002. While Schlesinger is undoubtedly correct in thinking that we are justified in suspecting design in the case where John wins 3 consecutive lotteries, it is because, and only because, we know 2 related empirical facts about such events. First, we already know that there exists intelligent agents who have the right motivations and causal abilities to deliberately bring about such events. Second, we know from past experience with such events that they are usually explained by the deliberate agency of one or more of these agents. Without at least one of these 2 pieces of information, we are not obviously justified in seeing design in such cases. As before, the problem for the fine-tuning argument is that we lack both of the pieces that are needed to justify an inference of design. First, the very point of the argument is to establish the fact that there exists an intelligent agency that has the right causal abilities and motivations to bring the existence of a universe capable of sustaining life. Second, and more obviously, we do not have any past experience with the genesis of worlds and are hence not in a position to know whether the existence of fine-tuned universes are usually explained by the deliberate agency of some intelligent agency. Because we lack this essential background information, we are not justified in inferring that there exists an intelligent deity who deliberately created a universe capable of sustaining life. What is your response to this?
All right, so trying to be brief, the first one I'd say, I don't need those pieces of information. All I need is a prior probability. So take the example of general relativity. If I'm going to say that the evidence we have is evidence in favor of general relativity, I don't need to know beforehand that our universe is, that general relativity describes our universe beforehand. That's the thing that comes out of the probability. All I need is that it's not ridiculously unlikely. I don't need information. I just need probabilities. And so I don't need to know that there is a that there is a designer capable of producing universes. I just need it not to be ridiculously unlikely. So again, you see in that quote, I think I found the right place on the internet. Where so I don't need that information. I just need to be able to put some sort of probability on it. And even if I think it's unlikely, it's the that probability, if it gets swamped by the other probabilities that are relevant to this question, then that's not particularly a problem. With the second one, I'd say that's just frequentis. That's just frequentism. The idea that you only get probabilities out of actual cases and counting numbers of actual cases is just a ludicrously restrictive idea about what probabilities are and when we're allowed to use them. It's a interpretation of probability known as finite frequentism. And if I'm analyzing what the response is supposed to be, and I only heard it once, so if I'm getting that right, then that's just way too narrow. Both for the fine-tuning argument, I'd argue that we have a broader picture of probabilities from a Bayesian perspective, but it's too narrow for science as well. We have to have already seen an example of something to know that in the past, to know that something in the present is an example of the same thing. Now, you'd ask the question, how you ever get started, if you never see, right? It's because you see the first thing and you think, I've never seen that before, so I don't know what it is. And then the second one comes along and you say, well, I've never seen that before, I don't know what it is. And then the third one comes along and you say, I don't know what that is, I've never seen that before. Right? You don't ever get started. You have to somehow have a sample of things that you know about before you can then see the next one. And so I'd say that that's just I think this is sort of Hume makes this mistake a bunch of times. It's just it's a way too restrictive, unnecessarily restrictive picture of how we reason and how we use probabilities. We can have novel explanations we've never seen before. If we can't have that, then science is in all sorts of trouble. You'd never discover a new species.
All right. So we had a question from Shaman. They ask, what are your thoughts on space being eternal, resolving the BGV as it would be the beginning of the expansion, but not space itself?
So, as I understand the Borda-Guth-Vilenkin theorem, if you're in the context of a theory like general relativity, I mean, space and time themselves are dynamic, and so you can't just fix them. They're variables in the equation in the theory, so you can't just sort of fix them as a background as you did as Newton did in his theory. So I don't think that would solve it. If you wanted to say that there's some sort of background space and try and eternal background space that is not dynamic, then you've got to explain basically how general relativity could work against that background. And I'm not aware of how that would work, but I can't say with any sort of certainty that it can't possibly work. But it's certainly not the normal way that people think about general relativity. In any case, I think if space forms an absolute static background, I think what the Borda-Guth-Vilenkin theorem might show then is not that space and time come to an end, but at least all the matter in the universe was in a singularity at one point. And so it would be a beginning of there'd be some very what do I want to say? Maybe you could say something like, at least there's a start to all the matter and energy in the universe, if not to space and time themselves, which I think is what Newton thought, space and time being absolute. No, maybe not. Yeah, I'm not sure. The unknown thing there for me is whether it makes any sense to say there is a static background space-time, and yet somehow general relativity is still true. So that I'm not sure about.
Okay, so I think D might have wanted to come on mic and clarify something about the last question that was asked.
Sure.
D, can you? Oh yeah.
Yeah,
you can talk.
I don't think that in that question there's a presumption of frequentism, and I'm not really sure sort of why you think that, because I don't think it's saying that there needs to be examples in the past. It's just saying for any explanation, like if you look at it from a sort of explanationist perspective, what's going to differentiate those types of outcomes for which we have justification from ones that we don't is, for any hypothesis, if that hypothesis is constructed to explain the explanandum, then it's not a very good hypothesis. So we can take the example where if in, like, by chance we lived in some universe where royal flushes were common occurrences, you might think that this is impossible, but like it's certainly not, like logically impossible that you could live in a universe where, by some sort of law of nature, you just get royal flushes all the time. You might want to put aside, for the sake of argument, some sort of, like, you might think that there are mathematical reasons that you can't live in a universe like that, like some laws of probability, but it's certainly conceivable. But the point is that when you make that type of postulation, if there's no if there's nothing to confer that hypothesis over any other hypothesis, then it just seems like the view is ad hoc. And if the view is ad hoc, then obviously it doesn't, like, it's not going to satisfy our explanatory virtues for believing in it. So the view there is just that it's supposed to be a type of undercutting defeater. It's just supposed to say that we should be skeptical of these types of inferences and the types of probabilities that we draw from them, because the point is that if you have a hypothesis that predicts any given phenomenon, like a designer or, a royal flush universe or something like that, then, conditional on the truth of that's going to be, the explanandum is going to be very high, right? And so then there's going to be, like, there's the whole question in Bayesianism about priors, like what's the prior for that we live in a universe that has, these types of laws or whatever, the royal flush laws or something. Maybe you might think that that's low or high or whatever, but the whole point of that objection is just it's supposed to be like, I don't think it presupposes frequentism, because you could give a Bayesian analysis for that type of thing. It would just be, on Bayesianism, you just have to be skeptical of priors, for example, like that type of thing. So I just don't agree with what you said about it presupposing frequentism or being restrictive about, the probability calculus it's using.
Okay, I think I found it. Let me just read. I think you're right, actually. So, just to set it up again, it's basically the 5 royal flushes come out whenever, in this case, John deals. And there's the, it's undoubtedly correct that we are justified in suspecting design whenever John wins in this way, but it's only because we know 2 related empirical facts. First, we already know that there exist intelligent agents who have the right motivations and causal abilities to deliberately bring about such events. Second, we know from past experience with such events that they are usually explained by the deliberate agency of one or more of these agents. Without these 2 pieces of information, we are not justified. We know from past experience that such events are usually explained by the deliberate agency or one or more of these agents. Well, there's 2 things. Yeah, so that's not quite frequentism. You're right. There's, I think, what do we want to say there? So there's two ways we could go here. One of them is to say, well, look, you could sort of bite that bullet. Yeah, past experience with very improbable, seemingly improbable things that actually serve a purpose happened because that outcome was chosen by an intelligent agent rather than being the result of pure chance, which is at the mercy of a large set of possibilities, most of which don't produce the outcome in question. And there's something sort of interesting and natural and remarkable about that particular outcome. Is to say that, okay, look, we have examples of that in everyday life, and so God would just be analogous to that. And so we know from past experience that events like this are explained by deliberate agency, and that's exactly the kind of proposal I'm putting forward. It's a supernatural agency rather than a natural agency, but the thing it's trying to explain is the whole of nature, and so that's just completely unavoidable. That's not any sort of objection. The fact that we haven't seen a supernatural agency before is just not any sort of problem, because the thing we're trying to explain is the whole universe, so it's not the sort of thing we could have seen. Or that doesn't count against it too much. Or you could say, look, we know from past experience that these events are usually explained by the deliberate agency of one or more of these agents. And we don't know that about the universe. We don't know how universes are made. Okay, we're still then... we're still not completely in a let's throw our hands up and just give up. So there's a move here that I like, which is in a number of places. Tim Mawson and some really, really good articles by John Hawthorne. One called Misconceptions About Fine-Tuning and one called Fine-Tuning, Fine-Tuning. An interesting title. Written with someone else's name I've forgotten, but John Hawthorne's the name you want to go for. One of the points he makes is that they make is let's test out this objection against a clear case where you would against the following scenario. You know, we wake up tomorrow morning and we look up in the sky and the stars have arranged themselves over our head to write out in English the first 14 verses of the book of John, right, from the Bible. In that case, you know, and astronomers are looking at it, and it really is stars. It's not just some joke that someone's done in the neighborhood. These are stars we knew about beforehand, and they've just moved over the course of the night in a way that seems completely physically impossible and arranged themselves in exactly that arrangement. Under those circumstances, like something's up. And if someone said, look, we know there's the sort of someone who wanted to spell out that message moved the stars in a way that is impossible for any finite physical agent. If someone objected, well, you know, look, whenever we make that sort of conclusion here on Earth, it's because we know already that those sorts of agents existed. Yesterday, before this happened, we didn't know that those sorts of agents were out there. So, look, we just can't say with any sort of certainty that this is because of that kind of, you know, at least, you know, it's sort of supernatural explanation. So I think in that case we'd say, look, okay, we didn't know about this before. We've never seen one before, but we've never seen this sort of evidence before. So the fact that we're proposing a scenario that is, you know, admittedly as yet unknown, but not a priori unlikely, it seems, and is needed to sufficiently explain this thing that we're looking at, is just the situation that the evidence has put us in, and there's not much. You know, it's no objection to say that we didn't know about this sort of stuff yesterday. But yeah, that's an interesting objection.
Well, if I may just respond to that, right? See, that I think the point is just of the type of explanatory virtues that are going on there, and I think what, you know, the problem with something like that is it trades on intuitions, it trades on you know, a bunch of assumptions about like what agents like us are likely to do. You know, you might think that if there were a person like this, they would be likely to do that. And so you have all these assumptions, but I think the point is that if you don't have any of those assumptions, right? If you like, if you're skeptical of that, like, let's take the fact that we're skeptical of theism, for example. If this is, it might be like, if a person had those types of assumptions going in, it might justify it for them, right? But if the point is that you have someone skeptical who already doesn't believe that, then that's no reason for that person to think that it was an agent over some natural phenomenon that we simply haven't encountered yet. Now, I feel like it was kind of weighted. The way you presented the argument was sort of weighted in your favor when it kind of, you said that it's you sort of stipulated that it's physically impossible. Well, of course, like, a person who's skeptical of this is just going to say something like, well, I don't agree that it's physically, like, it might be inconsistent with the laws that we are positing now, and maybe it's even drastically inconsistent, but that could just give me a reason to be skeptical about the natural laws. It's so I think the point there is just that it's on an explanatory parity with a natural explanation that is simply concocted to explain the thesis in question, and really the thing is like, it's more about what it's rational to conclude, because it might even be the case that, like, people are prompted to conclude that it was some supernatural agent, although, I certainly like to think that I wouldn't conclude that after I saw something like that, but were I to conclude that, it doesn't say anything about the rationality of making that type of inference, as opposed to there being some natural explanation of some extremely bizarre coincidence, and the point is that you might think that the natural explanation for the extremely bizarre coincidence is supremely unlikely, but the point is that the evidence is likely on the hypothesis, right? And if I'm skeptical either way, like, if I'm skeptical that there's an agent, or if I'm skeptical that there's such a natural law, you haven't given, like, a person who thinks in that way any reason to move one way or the other. So that's kind of would be my response to that.
So just quickly, three things. There's a very good paper by Neil Manson which presents this objection, which you might want to go and read. Which I think it's sort of, I think that the point you're getting at, I think that's the best sort of presentation of that. I think there's one thing you said where actually you need a slightly stronger assumption. You said if someone doesn't already have those assumptions, or if someone doesn't already believe those things, then they won't be convinced. And I don't think that's correct. I think you'd have to set your prior probabilities for that hypothesis to be extremely low. So it's I mean, it's certainly the thing turns up in the night sky, and someone says it would be unreasonable just to say, well, I mean, I wasn't thinking that sort of thing was possible yesterday, or that there could be that sort of agent yesterday, so therefore I can't think it's possible today. It's not enough that you don't have those assumptions. It's the question of what prior probability you had on those assumptions yesterday. And if they're not ridiculously low, then the evidence could change your mind, and you'd hope that it would. And so finally, I'm just reminded by a quote. Bertrand Russell was asked, if he gets to the afterlife and he turns up in heaven, and God says, "Why didn't you believe in me?" Russell says, I'd look him right in the face and say, "Not enough evidence." And it seems like if God wrote the first 14 verses of the book of John on the night sky, and people still didn't believe, they certainly wouldn't be able to say that to God if they came face to face. God would quite rightly say, "Come on, really?" But I'll leave that there. That's a sort of that's a very interesting discussion. Yeah, Manson's paper is quite good on this. My paper, a reasonable little question which I published, has some my responses to that. So we can get into that in more detail.
Okay, I respond. I think we'll leave it there. I don't want to be disrespectful of your time.
All right. Well, appreciate your questions, Josh. And we're coming up to past the 90-minute mark here. So I guess we're going to wrap up around now, if that's okay with you, Dr. Barnes.
Cool.
Do you have anything you'd like to promote before we end off? I know you've talked about your book a little bit. You can bring that up again, and anything else that might be coming out soon or might have come out recently that you want to talk about, or any you can talk about your website or YouTube channel or whatever. Anything you want to promote, you can do that
Oh,
now.
I think I've dropped a whole bunch of stuff in if people were paying attention. So yeah, the book and a recent paper of mine called "A Reasonable Little Question: A New Formulation of the Fine-Tuning Argument." It's out in Ergo, the journal. That's my sort of best attempt as a not as a philosopher. I'm not a philosopher, right? I'm an astrophysicist. Right, my best attempt to do the sort of philosophy of the way I see this argument is supposed to work. So if you want to dig in deeper, I think that's the place to go. Or the book, if you just want to understand the physics. Like I said, most of it was written with an atheist friend of mine, a colleague of mine. So, yeah, a fortunate universe. Dig into either of those, and a YouTube channel, all that stuff. Yeah.
All right. Well, I have put your website and YouTube channel and a link to where people can buy your book. I put all that in the AMA discussion chat, and really appreciate you coming and doing this, Dr. Barnes.
Thanks, everyone. Really good
We'd love
questions.
we'd love to do this again sometime in the future. If you'd ever like to come back, we're always, looking for to have more events like this. And for anyone watching on the YouTube channel, if you aren't in the server already, we have events like this regularly, and we also, like to facilitate interesting discussions. So come by the server if you're not already here. But with that, I think we're going to end off. Dr. Barnes, thanks again for coming. You're free to
Thanks.
go now, and anyone else who wants to stick around and discuss the AMA or anything else, you can move down to the general voice channel or the other channels.
Cool. Thanks, everyone. A pleasure.
Have a good night, Dr. Barnes.